Hello, my name is Gabriel, and I'm going to show lab number 1, charge tapes. As an introduction, the objective of this lab was to estimate how much excess charge is on pieces of charged tape, and also create a computational model that would determine the tape's charge. The materials needed for this lab were a tape, a ruler, and the glow script to develop the model. My results indicate that the tape charge was positive 8.1018 10 to the negative 9 coulombs for the experimental section, and my model showed that the tape charge was equal to positive 8.1 10 to the negative 9 coulombs. Going forward onto the fundamental principles used, the main ones were Newton's second law, where force is equal to mass times acceleration, Coulomb's law to establish that the electrical force is proportional to the charges, and inversely proportional to the distance squared. Going on to the gravitational force, this was used to estimate that the gravity force was equal to the mass of the tape times gravity. Some general assumptions made were that the charged tapes behave like point charges, the air resistance is considered negligible, the charged tapes have equal charge because they are made from the same material and prepared in the same way, and also that some losses could happen due to tape handling, losses of electrical charge. Going forward onto the experimental guide, the system analyzed was tape B, as shown in the picture here. The surroundings were considered to be tape A and Earth. As for the initial conditions, tapes A and B, called U tapes, were initially neutral, and a third base tape, a neutral tape, was attached to a flat surface. As for the instructions, we were instructed to stick tapes A and B onto the base tape and then quickly rip them off to build up charges. After, without disrupting those charges, we should hover tape A near tape B, as shown in the picture to the right, until the system stabilized, as in tape B didn't move. After that, we should measure the distance between the tapes and then determine the magnitude of the forces. Additionally, we were instructed to prepare a negative object by rubbing a pen onto my hair. For the observations, tape A and tape B repelled each other, which suggests that they have similar charges. The base tape was attracted to my hand, which means that the base tape and my hand had opposite charges. Tape A and the negative pen were attracted to each other, which means they have opposite charges. And therefore, tape A has a positive charge, and based on the first assumption, tape B also has a positive charge, which leads us to conclude that both U tapes lost electrons and are also positively charged. For the calculations, the measured tape length was of about 0.18, the tape width 0.02 meters, the tape mass was about 1.823 10 to the negative 4 kilograms. The distance between the tapes when they stabilized, tape A and tape B, was 0.018 meters. Gravitational force was calculated by gravitational force fundamentals, which is mass of tapes times gravity, which leads to 0.0018 newtons. The net force, because the system had no acceleration, acceleration is then zero, which leads to a zero net force. And the net force of the system was electrical force plus gravity force. And therefore, the electrical force is equal to the gravity force, 0.0018. It is important to make sure that gravity force and electrical force are opposites. So therefore, depending on the axis you consider, one of them is negative, the other one is positive. But this is only the magnitude. The charge was then calculated by using Coulomb's law, and another key assumption made was that both tapes had equal charge. And therefore, Coulomb's law will be reduced to K times Q squared over D squared, which is equal to the gravitational and the electrical force. With that in hand, the charge calculated was of about 8.2 10 to the negative 9 coulombs, 1.8. Going forward on to more calculations, electrical deficiency was calculated by dividing the charge per the electron charge, which led us to calculate a number of electrons of around 5.11 10 to the 10. The total atoms was calculated by the area of the tape, which is length times width, divided by one single atom area, which was a constant given to us. The total atoms calculated were 3.61 e to the 17 atoms. We also calculated a ratio of electron deficiency divided by total atoms. It is important to mention that it is electron deficiency because the charge of the tapes was positive. This value was obtained to be 0.714 10 to the 7 electrons per atom. Atoms per electrons. Going forward, this is the model build, the code shown to the right, which performs basically the same calculations for the experimental values. And it defines tape A and tape B as two spheres. Tape A is the blue sphere, and tape B is the red sphere. As you can see, the tape charge's magnitude was very similar to the one experimentally measured, 8.1 times 10 to the negative 9. The efficiency was also very similar, and the ratio between the two atoms was similar too. This is a graphical representation where the green arrow shows the electrical force between the two tapes, and the blue arrow shows gravitational force acting on tape B. For final discussion, we were asked, what if electrons had positive charge and protons had negative charge? And basically, the observations will be the same. The tapes would still be attracted to neutral objects, like my hand or a book, and the tape A would still be attracted to the negative pen, which would in case be a positive pen. But still, the only thing that will change is the actual sign of the tape charges. And also, why is it important to handle the charge tapes as little as possible? This is so that the tapes could lose charge or be neutralized if they touch any objects. For the conclusion, we can understand that everyday objects can be used to observe critical interactions. With simple experiments, we can determine charges. Objects can also be accidentally neutralized or charged with touch alone. And electrical forces with Newton's second law are very powerful tools to understand interactions in the world. Thank you.